Cool, so now we're going to move on to the next part. And we see that min-max is a recursive problem. And what we want to do is return some tuple that has the min and it has the max from some given list S. And so we see that we've already given the structure for a recursive problem. We have our base case, and then we also have our recursive case. And so what I'm thinking right now is, why don't we just do some base case and see where it takes us? So our base case, I know that I want to return some tuple. And so if I have some list, like let's say S was some list like 3, right? I know the min of my list and the max of my list are both 3, right? So I think it makes sense to tentatively put down that my min and max in this case would just be S0 and S0, right? So once we have this tentative base case, we'll try to see if we can solve the problem from here. So moving on to a recursive step, we see that we probably want to be making our list smaller and smaller and smaller in order to hit our base case, right? So in order to do that, I'm probably going to be passing in a sliced version of my list. And also, I need to be able to find our min and max. And I know that ultimately I'm going to be returning a tuple, so I'm probably going to have some tuple in my return statement. So with all that, I want to, now it's kind of had like how we would logic through a recursive problem like this. So what I probably want to do is see if my the 0th index of my list S or the min from the rest of the list is smaller, because then I would have the smallest value in our list, right? So if I have like, just to kind of like walk through the idea, if I have some list 1, -2, 3, right? If I compare the min of, if I take the min of the 0th index and then the min of the rest of the list. Oh, sorry. I mean, if I take like min of S0 and then I have the min of the rest of my list somehow, then this will give me the ultimate min of my whole list, right? So in order to do that, I'm probably going to have some min, and I'm going to have to compare it against some S0 and the rest of my list, and same for my max, right? I'm going to be doing max and comparing it against S0 and the max for the rest of my list, right? So now we have to figure out how we're going to do that. So I remember that whenever I call min max, I'm going to have to return a tuple, right? So I know that I can split up that tuple by doing this, right? So the first element in the tuple is going to be assigned to min of rest, and the second is going to be assigned to max of rest, right? So if I trust that my recursive call is going to be giving me the min of some list, if I call it, the min and max of some list, so if I call it on S and sliced, right? If I trust that this works, then it's going to give me a min, it's going to give me a max, and that, in my very top recursive case, is going to be the min of my rest and the max of my rest. And also, it's going to be true for the rest of all my calls too, right? So once I have this, I can just put this here and max of rest. And then this will be able to return me the ultimate min of my list and the ultimate max of my list. And then this also works because if I check my base case, right, I'm going to continually slice, and then I'm going to get to a point where I've sliced all the way and I have one value left. And then I'm just going to return that as a tuple of the same things. So if we go all the way to our last case for this this list, right, I'm going to have min of -2 and that, and then I'm max of -2 and something, right? And then our base case is going to return us some tuple that's going to be 3, 3, right? The min goes here, the max goes here, 3, 3, right? And so this will give me -2, this will give me 3. And so this will keep going up the recursive stack too, but we can see that our base case works because it gets me the proper min of my my list up until that point, at that point, and the proper max of my list at that point too.